Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we're going to talk about production. The production function is the relationship between the quantity of inputs used to make a good and the quantity of output of that good. As with the supply and demand functions we've worked with in the previous sets of videos, we can represent a production function in one of three ways: an equation, a schedule, and a graph. In this course, we are only going to use the schedules and graphs. Using an equation to represent the production function is really going to require us to use calculus, so we are not going to do that here. I'll leave that for a later course. When discussing production, it's important to understand what the time horizon is. The reason for this is that some inputs are more easily adjusted than others. For now, we're going to think about production using just two inputs. It's absolutely possible for a production function to involve lots of different inputs, way more than two, but we're going to limit it to two so that we can learn the concepts while keeping things as simple as possible. The two inputs we're going to be thinking about are the two basic ones in econ, which are labor and capital. Labor represents the workers used in production. We might measure labor in worker hours. Capital has a very specific meaning in economics, and it means the physical equipment used to produce a good. This could be something like machinery, tools, buildings. All these kinds of physical items are considered capital. This is distinct from the finance use of the word or the geography use of the word. In econ, we always mean physical equipment. Generally, increasing the amount of labor or capital used in production will increase the total output. In the short run, some inputs are fixed. We usually think about capital being fixed in the short run. If we want to increase capital, this might involve something like increasing the size of a factory. This takes a long time to do, and so we generally consider this impossible in the short run. Labor, on the other hand, we consider to still be variable in the short run because it's relatively simple to hire another worker. In the long run, all inputs are variable. There is no specific amount of time that distinguishes the short run from the long run. The long run is defined simply as the amount of time that it takes to make all the inputs variable. For example, how long it would take to be able to change the size of a factory. The amount of time required to get to the long run varies greatly by industry, technology, and so on. We're going to start out by focusing on the short run, meaning that we're going to have a certain level of capital, and that's what we're stuck with. The only way to change the level of output is to change the amount of labor involved in production. To illustrate the concepts going forward, we're going to be thinking about an example. In our example, we have a factory that can hire up to 10 units of labor, and it has a fixed amount of capital. The total cost of all of this firm's capital is 20. So no matter what the amount of labor is, the amount of capital stays the same. No matter what, we cannot change this in the short run. Each unit of labor is paid a wage of 10, so I've filled in both of those on the table. Marginal product is the increase in output resulting from an increase in inputs. If we have more than one input, we can talk about the marginal product of each of those. In the short run, labor is the only thing changing here, so we're only thinking about the marginal product of labor. When we have zero labor, we have zero total product. But when we have one unit of labor, we have 20 total product, so the marginal product of that first unit of labor will be 20. There is no marginal product at 0. When we hire the second worker, we go up to total product of 38, so what was added here was 18. Going up to the third worker, we go up to 54, which is an increase of 16, and then we can continue filling this table in all the way down. Think of the marginal product as the rate of change of the total product. This makes the marginal product the slope of the production function. I've used the computer to graph out our production function. On the horizontal axis, we have the amount of labor that goes from 0 to 10. The vertical axis, we have the total product. Notice the shape of the production function. It starts out steep and then flattens out as labor increases. The slope going from each point to the next is the marginal product. Here you can see the marginal product is 20, and for the second one we can see that this distance is 18, and so on. Each unit of labor added adds less to the total production than the last one. This property is known as diminishing marginal product. This is a general property that we will see in most production functions. The intuition behind this is that in the short run, the amount of capital is fixed. Capital, remember, is factory, equipment, things like that. If that's fixed in the short run and we keep adding labor, eventually our facilities start to get crowded, workers get in each other's way, have to share equipment, and so even though adding more workers does increase the total production, each successive one is going to add less to the total output. The slope is still positive, but the increases are happening at a diminishing rate. We'll now graph out the marginal product of labor. At 0, we have no marginal product of labor, but at 1, we have 20. At 2, we have 18, and I'll just keep graphing these points. I'll connect these up with a line, and we can see that this graph reflects the diminishing marginal product of labor. The more labor we already have, the less the next unit of labor is going to add. The decrease in the marginal product of labor corresponds with the flattening of the production function. We're now going to think about how much this production will cost the firm. Once we have all this information about the production function, we can use that to build the short-run total cost function. First, I'm going to fill in our labor cost column. We'll do this by multiplying the amount of labor we have by the wage rate. When there's 0 labor, we have 0 labor cost. When we have 1, 1 times 10 is 10. 2 times 10 is 20, and I'll continue filling that in all the way down. Since capital is fixed, that's never changing, the capital cost will stay the same. To get the total cost, we will add up the costs of all of our inputs. 0 plus 20 is 20, 10 plus 20 is 30, and so on. Next, we're going to look at the graph of the total cost function. The total cost function will have the total product, or total output, on the horizontal axis, and it will have total cost on the vertical axis. As total product goes up, total cost is going to go up, and it's going to go up at an increasing rate. Let's just take a look at one of these points. This tells us if the total product is currently 80, that's going to cost us a total of 70 to produce. We can see that lines up with 80 and 70 in our chart. The reason why the total cost function increases at an increasing rate is because our production function increases at a decreasing rate. They are essentially inverses of each other. Thinking about the total cost, if we want to increase the total product by a certain amount, if we already are producing a lot, we're going to have to hire even more workers than we would if the production was currently low, because of diminishing marginal product. Looking at the graphs side by side, we can see this relationship. If you were to sketch the production function, the graph on the right, on a piece of paper, flip over the paper and hold it up to the light, you would see the total cost function. The only difference is that the total cost function starts here at 20 because we have 20 fixed capital cost. Now that we've established what the total cost function is going to look like, in the next video we are going to analyze it further.